Hi Pre-Calc, we're going to look at determinants and inverses of matrices. I've got the checklist on the screen, you know what to do from here. First of all, on the screen, can you go ahead and copy what I have? Alright, so first let's define what is a determinant. Well, for a 2 by 2, a determinant is your elements on your major axis multiplied together minus your elements on your minor axis multiplied together. Here's what I mean. So if I want to find the determinant, abbreviated DET, of this matrix A, I'm going to multiply A times D, and then I'm going to subtract, and then I am going to multiply B times C. And that is a determinant. All right, so take that and find me the determinant of this matrix A. Hit continue when you're ready to check your answer. All right, we should have gotten 4 minus negative 3, or 4 plus 3, which is 7. If that's not what you got, go ahead and pause and correct. And first pause on your screen, can you go ahead and copy these two matrices like this? We're going to go ahead and multiply them together. All right, so let's go ahead and try these two. I've got a 2 by 2 times another 2 by 2, so is matrix multiplication possible here? It sure is. And what is my result going to be? What order is my final matrix going to be in? Another 2 by 2. Okay, so remember, let's take this row times this column. So 1 times 1 is 1, and then let's do that to the side here. Plus 4 times 0 is 0, so I am getting 1, right? Okay, now to find this piece, we are going to take first row here times second column here. So I've got 1 times 0 plus 4 times 1, which is 4. First pause on the screen, can you fill in the last row for me? Hit continue when you're ready to check. All right, our last row should be negative 1, negative 3. Notice that our result is exactly what we started with here. And why is that? Do you remember? Because this is what we call the identity matrix. This is I sub 2, because it's a 2 by 2, okay? And remember, whenever we take a matrix times the identity, it's like multiplying by 1. So we just get our original matrix back. So if I take a matrix times the identity, that's like multiplying by 1, I get that same matrix back. But can I go the other way? Is there kind of like this idea of dividing by matrices, which is a yes and no. Let's think about going the other way with real numbers. A times what is equal to 1? Well, A times 1 over A, right? Also known as A to the negative 1, the reciprocal. Or maybe we could say the inverse of A, okay? Matrices have a similar property where we take matrix A times what's called the inverse of matrix A, and what is 1 like? The identity matrix. So if we're taking, for example, like a 3 by 3 times its inverse, then we should get the identity 3 by 3, so that the I sub 3 looks like this: 1, 0, 0, 0, 1, 0, 0, 0, 1. Okay, so there is, as opposed to something like one identity with real numbers, you have multiple, infinite number of identities for matrices because it depends on your order or your dimension. So our next task is going to be, well, can I figure out what the inverse is? So if I give you A, could you figure out A inverse? Let's explore two matrices. I'd like for you to write these matrices down exactly as is, and then go ahead and multiply them together. Hit continue when you're ready to check your answer. All right, so we should have gotten 1, 0, 0, 1, which is the what matrix? This is the identity matrix, meaning that these two matrices are what? They're inverses of each other. Okay, now take a look and see what patterns do you notice between the two matrices that I gave you originally. I'm going to highlight some things for you. I want you to compare those values with those values. What do you notice? They're flip-flopped, right? So I flipped A and B. Now take a look at your minor diagonal. Take a look at those elements versus those elements. Are they flip-flopped? Not quite. What's different? The signs are different. So if this is element B, for example, B becomes negative B. And if this is element C, this becomes negative C. Just change the signs, right? So let's generalize that. So here's our shortcut. If I have a 2 by 2, then matrix A, if matrix A is A, B, C, D, then the inverse is 1 over the determinant of A. I'm going to flip my elements on my major diagonal and switch the signs on my minor. Now, you're probably like, whoa, 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 where did this 1 over determinant of A come from? Well, the reason it didn't pop up on this one was, let's find the determinant of this matrix here. So I do 1 times negative 3 minus 4 times negative 1. So I'm getting negative 3 plus 4, which is 1, and 1 over 1 is 1, which is why you don't see that pop up in this particular example, because I wanted you to really focus on the elements. But you can see if I do 1 over 1, I get what we got earlier. Okay? Now this is true, of course, as long as the determinant of A is not equal to 0. So in first pause on your screen, go ahead and copy what I have for the shortcut. All right, go ahead and copy this example and then find me the determinant by hand. Hit continue when you're ready to check, and I'll show you how to do it with the calculator as well. All right, so remember we're going to follow this formula of 1 over the determinant times this new matrix where we switch the elements on the major diagonal and change the sign of the elements on the minor diagonal. All right, so the determinant, I got 6 minus 2, which is 4. So I'm going to do 1 over 4, because it goes 1 over the determinant, remember that? Okay, and then I'm going to switch these two elements. So this becomes a 2, this becomes a 3. I'm going to change the signs of these two elements. This becomes positive 1, this becomes positive 2. And just think of distributing that 1/4 to every single element. So I get 1/4 times 2, which is a half. And then this is 1/4, a half, and 3/4. All right, you can also use matrices to solve systems. So we used RREF to solve systems. Another way is to use inverses. On first pause on your screen, go ahead and copy the system. All right, so what I'm going to do is I'm going to start by making 3 matrices. So I'm going to make 1 matrix for my coefficients. So let's do that. So I'm just going to grab the coefficients for each row, the coefficients on the variables. So I've got 1, negative 2, 3, negative 1, 3, 0, 2, negative 5, 5. Now I'm going to multiply each of those by a column matrix for my variables. So I want to take these coefficients times x, y, z, because this row times this column would be 1x minus 2y plus 3z, right? And I want that to equal 9, okay? So I'm going to equal, now leave some space, and now make a column matrix for your constants. So my constants are 9, negative 4, 17. Okay, so what we're going to do, what I'm trying to do is solve for x, y, and z, right? So I want to get rid of these coefficients. Let's call this matrix A. Well, what times matrix A gives me the identity? What would get rid of it? Would multiply by A inverse. And notice I'm multiplying on the left-hand side, so what I do to one side of the equation, I need to do to the other. Okay, alrighty. So let's look at how to find inverses on the calculator. So let's practice typing it in again. You're going to go to alpha F3. This is a 3 by 3. And hit OK. All right, so I'm going to type in my elements. Go ahead and do that and then hit continue. I'm going to do mine as well. All right, so hopefully I've got this all typed in correctly. And then I'm just going to hit this inverse button right here. Ooh, it freaked out on us. Okay, so this inverse button right under math. Then I'm going to hit enter. And there's my inverse, okay? So here's A inverse. Now I want to take A inverse, remember, and multiply by this column matrix 9, -4, 17. So I'm going to multiply, I'm going to take that times, and let me grab a new matrix. And remember, you can do this on that Desmos matrix calculator as well. So I want 3 rows, 1 column, takes its sweet time here. Okay, and it is 9, -4, 17. And that should be my X, Y, and Z right there. Now, what I'm really interested in, if you prefer reduced row echelon form, just RREF of the augmented matrix, by all means. What we're really interested in is, can you set it up? Okay, so here's what I'm going to ask you to do. Here's our system. Okay, can you plug in the coefficients, the variables, and the constants for me? Okay, so try just filling in this, and this for me first. Hit continue when you're ready to check your answer. All right, let's see how you did. For your coefficients, we should have gotten 18, 12, 30, and 24. And for your variables, you should have gotten X and Y. And then for your constants, we should have gotten 13 and 23. Okay, now can you go find the inverse of this matrix for me? All right, so just put it in the calculator and do a little exponent of -1. If you're using the Desmos calculator, here's the inverse part, and by the way, here's the determinant part if you're using Desmos. So go ahead and see if you can find a inverse for me. Hit continue when you're ready to check. All right, we should have gotten this for the inverse, which I want to put in both locations, right? What's going to happen is then these two multiplied together go away, so I just get X, Y equals whatever those two matrices are multiplied together. But again, what I'm really more concerned about is setup here, more than using this method, because the setup really shows, do we understand what each part of the matrix equation does, okay? All right, one last thing, I'm going to show you where to find your determinant button on here. So if you go to second matrix, go to math, determinant is the very first one, okay? So if we come back to that example we were doing, right here we found the determinant of this. So I can go determinant and then alpha zoom, do a 2 by 2. Let's see if we get 4 again. Just want you to, whatever calculator you have, you know how to work. It's either like 84 or the Desmos calculator. So we've got 3, -1, -2, 2. We got 4 by hand. Let's see if our calculator gets 4 as well, and it does. All right, y'all, that is it for today. I'll see y'all next time.